All right, hello again, pre-calculus people. Last video we talked about graphing exponential functions. Today we're going to talk about graphing logarithmic functions. I did talk about in class the relationship between exponential and log. We'll talk more about that next week too. But here I'm just going to talk about the transformations and kind of what we're going to be looking for when we're going to ask you to graph one of these things. Okay, so if you know what an inverse means, literally it's going to take the properties of the exponential and kind of reverse them, for lack of a better term. So for this case, the range here is going to be all real numbers, or negative infinity to infinity. And the domain, of course, we're talking about the parent function. The domain is going to be from 0 to infinity. I did make a table of values here that I just pulled off the calculator. And again, for this, I'm using base 2, just to make it kind of a little easier with number-wise. So my vertical asymptote is going to be along the y-axis, or at x equals 0. And then my critical point, which I talked about yesterday, is this guy right here. So my critical point is at 1, 0, and then 2, 1, and then 4, 2. And then it actually goes to 8, 3, and then kind of down like this. So this is what the graph kind of looks like. It does go up forever, so it's asymptotic along the asymptote, and then kind of goes up forever. It does go up very, very slow, but it does go up the whole way. That's where you can see what the domain and range is. Okay? And then again, I did mention that critical point. That critical point we're going to be looking at is the point 1, 0. And that's what's going to move. That's, when you do your transformations, that's how that's going to change. Just like yesterday or the previous video when I talked about graphing exponentials, when we're looking at graphs of logarithmics, really, if the asymptote's in the right place, if the critical point is in the right place, and if the general shape of the graph is good, I'm not going to get too terribly picky after that. Okay. Another note, remember yesterday we had like 2 to the x or e to the x, something like that. Logs work the same way. That base value can be anything. It's really not going to change the shape of the graph a whole lot. Again, the main thing is the critical point is going to stay the same. The asymptote is going to be the same. The base just changes a little bit of the steepness and some of the individual values. Okay. So let's go and move on down to our transformations. This is exactly the same as exponentials. I'm going to write these in real quick. Again, all we're really worried about for A is if it's negative, and that's a reflection across the x-axis. If B is negative, that's the inside part. That's if you have a negative x, that's a reflection across the y-axis. And then H and K, we know that's our shifting right or left for the H. And the K is the shift up or down. Okay. Last note here, and this is just kind of a little pet peeve of mine. So this right here, if you're not familiar with this, is LN. Whenever I write it by hand, I always do a cursive L. It drives me bananas. Every year, I have a few students that decide to write that as a 1N because they see it typed and it looks like 1. It is not a 1, it's an L. LN stands for natural log. And we'll talk more about that again coming up here soon, but just know when you write it yourself, make sure you know that is an LN to kind of go forward from there. So just like yesterday, let's look at a couple of examples. I'll graph them. I'll let you pause the video and do a couple on your own, and that'll be that. So example A, notice all we're doing here is just a shifting. So in this case, my H is -4, so it's going left. And my K is -1, so it's going down. Okay. Remember, for log functions, the range is always going to be -infinity to infinity, not going to change. But then the domain, remember, if I'm shifting this thing left and right, the asymptote is going to shift with it, right? And the domain is going to change with it. So the good news is the vertical asymptote always is going to be x equals h, so in this case, -4. And the domain, if it's not being reflected, is going to be the same as the parent function. It's just going to go to h instead of 0. So from -4 to infinity. If there's a reflection, that could also be backwards, for lack of a better term, but we'll talk about that in the next example. So I'm going to go and graph this on the next page, and then we'll come back and do the next example. So again, we're looking for three things. I'm looking for the asymptote. So we said the asymptote was -4. All right, about there. We're looking for the critical point. And remember, just think of the parent function critical point here, 1, 0. Shift it 4 to the right. I'm sorry, to the left. So 1, 2, 3, 4 to the left, and then down 1. So my critical points can be right here at -3, -1. Okay, and then after that, we just want to get the general shape. So again, it's not being reflected at all, so it's the same as the parent function. So asymptotic, kind of swooping up here, coming through the critical point. And then after that, going up there pretty slow, kind of like that. And that is the graph of natural log of x plus 4 minus 1. Okay, let's go and look at the second example. And remember, anytime you need to pause the video, if you need to go back and take a look at one of the previous examples or rewatch, you can always do that too. So in this case, I got a log function. The minus is inside. Remember, that's our b value on our kind of format. So this is a reflection across the y-axis. And if you think about what that means just shape-wise real quick, so parent function, we know what that looks like now. If it's going backwards across the y-axis, that means in general, it's going to look kind of like this, right? So think about that for a second when we get down to what the domain of this function is. So the other transformation, though, it's also going right to, h is +2, so it's going right, and k is +3, which is going up. Okay? Range is always the same. And then again, take a look at just a super rough sketch on this one, but notice if it's going across the y-axis, going backwards, my domain has also kind of gotten flipped. So in this case, my domain is going to be from -infinity to 2. Again, still that h value. And the VA will be x equals 2. Okay? So let's see what that looks like on a little better graph here on the back. So again, so we said it went right 2, so my asymptote is at 2. Critical point, and again, same warning as exponentials. We need to do reflections first before we do any kind of shifting. So again, so we started at 1, 0. We reflected over the y-axis, so it flips over to -1. And then we go right 2, so we're kind of back to where we started. And then we go up 3. So my critical point is going to be at the point 1, 3. And then for the shape, again, we're going backwards. So it's going to go off to the left. So asymptotic, it'll swing up here to the critical point and then go on up from there. All right, so there's 2 more examples. I encourage you to pause the video for just a second. See if you can graph these things by yourself. And then I will zip through and finish up these 2 for you. All right, so hopefully you got those done. So let's take a look at them. So first things first, we know that minus ln, and mind the order here, okay? And because this 2 out here, don't get confused, this is still a k value. But that minus in front of the log function, that tells us we have a reflection across the x-axis. We're going left 1, and we're going up 2. Remember that k, even though it's not on the end, we just kind of rearranged it. It's still a vertical shift. Okay? Domain, again, the only time the domain is going to change if it's getting flipped across the y-axis. Going across the x-axis doesn't affect the domain. So it's going to be from 1, negative 1 I should say, negative 1 to infinity. And then the VA, x equals negative 1. So draw your asymptote in there. I like doing that first. Critical point, 1, 0. Reflecting across the x-axis doesn't change it at all. So then we just go left 1 and up 2. So my critical point is right here at 0, 2. Okay? And if you think about it being upside down, so let's take a look at this guy. This is kind of like the parent function. If I flip it upside down, now it's going to be swooping down from the asymptote on top and then go off kind of down to the right. So kind of like this. So that's a reflection across the x-axis. And then last one, this has the whole caboodle. So reflecting across both axes. It's going right 3 and down 2. And again, since it's going across the y-axis, my domain is kind of backwards. So negative infinity to 3. And the VA, x equals 3. So 1, 2, 3. Critical point starts here. Reflected, so it's going to get over to negative 1. And then right 3. 1, 2, 3. And then down 2. So my critical point is right here at 2, negative 2. And then if you think of it, again, backwards and upside down. So here's my upside down one. Now if I go backwards, so it's going to be coming down from here and then going off to the left. Okay, so let me finish this up. Let me kind of zoom out a little bit so you can see all 4 graphs at once, because that's really all the only 4 combinations. So this is like regular. This is backwards, reflecting across the y-axis. This is upside down. And then this is both backwards and upside down. And that's the only combinations you're going to get, really. Okay, so make sure you're comfortable with graphing these simple transformations of exponentials and logarithms. As always, if you have any questions, you can come into tutoring, ask a question during class. Until next time, stay safe.